Hi, I'm Tarsh, and this is Godot Agent. I built it to reduce the time between a game idea and a playable prototype. Normally, the loop requires choosing a gaming engine, creating or finding assets, writing scripts, exporting to the web, debugging, and finally getting the result that you want. The bottleneck here is not just the code, it's the full end-to-end working prototype pipeline. This project tries to compress that workflow into a system that takes a natural language prompt and produces a playable Godot web game. I start with one natural language prompt, a cozy 2D platform where a cat can collect yarn balls in the Moonlit Bakery. The goal is to turn this directly into a playable Gadot web game. The front end streams the constructive process live. These five stages shown in the back end are doing 1. Designing the game, 2. Revolving assets, 3. Synthesizing Gadot code, 4. Exporting the build, and 5. Running the browser QA. This is the architecture. A prompt enters the React frontend, then post API generate calls, the fast API backend. The backend runs a five-stage pipeline that designs, assesses, synthesizes, and builds the browser QA. This file orchestrates the whole flow and the bounded repair loop. If synthesis export in QA fails, the system can spend a limited repair budget instead of retrying forever. The model does not freeform invent a game. It produces a validated game design schema with a template, controls, mechanics, assets, palettes, shaders, and wind collections. This makes the generation structured and debuggable. The asset phase calls providers like Pixel Labs, OpenAI Image Generation, and Triple. If they fail or time out, the resolver falls back to loadable assets, so generations can still produce a playable game. This build step runs Gadot headlessly and exports the generated project as a single-threaded web build, so the project is an actual browser-playable game, not just plain code. And this hook consumes streamed backend events. It updates the face cards, the asset thumbnails, controls save games, and swaps the final build into the iframe. The core idea is constrained AI generation. Schemas, templates, engine feedback, and stream progress turn a prompt into a playable game. Instead of asking an AI to write a whole game blindly, the system gives a structure and checks the results in a real engine. After waiting about 7 minutes, this is the result of the cat prompt. A cozy 2D platform where a cat can collect yarn balls in a moonlit bakery. And the important thing here is that the output is not a mockup. It is a Gadot web export running in the browser, and it is also savable locally. I also evaluated the system through backend regression tests, front-end production builds, local smoke tests for server game behavior, and prompt trials, including 2D platform, top-down 2D regression, 3D walkers, and vague prompts as well. Right now, 2D is the strongest path, while 3D is less reliable because asset generation and template coverage is slightly weaker. If I continued on this project, I would like to add more templates, improve 3D reliability, and ensure that multi-turn editing is possible in this process of one-shot generation. And most importantly, I want to add user accounts to save games as well. AI tools were used to both produce the product itself and in during development environments, and this usage disclosure is in the README as well, along with a lot of the source edit. Here's a second prompt using a different template. A top-down 2D arcade game where a gardener dodges slimes and gathers seeds. Right now, 2D works best because the template and asset generation are more reliable. A larger goal is a one-person game prototype lab. Game jams, classrooms, indie prototyping, or quick testing mechanics before investing days into a full build. Thank you so much.